Welcome back, everyone. Today, we're diving right into a brand new explainer, and we're looking at something I find absolutely fascinating: the science of facility layout. We're going to demystify how the physical arrangement of space isn't just about making things look nice and tidy. No way. It's literally the engine driving organizational success, efficiency, and competitiveness. Let's get right into it. Think about a poorly designed factory floor for a second, or even just a chaotic office space. It doesn't just look messy, it actually literally costs money. We're talking dreaming profits, a sharp drop in output, and even a really dangerous increase in workplace accidents. Imagine paying top dollar for highly skilled experts, only to watch them waste hours hauling boxes across the room just because the floor plan is working against them. It's wild, but that's the frustrating reality of a layout that doesn't support the workflow. Now, you might be wondering, redesigning a massive facility is a huge, incredibly expensive undertaking. So, why do organizations suddenly pull the trigger and overhaul their entire workspace? Well, they certainly don't do it just for fun. The need usually pops up when they're forced to relocate, or more often, when their existing layout stops being a helpful asset and starts acting as a massive bottleneck to their efficiency. Okay, let's look at what actually drives this. A redesign is usually triggered as a critical competitive weapon when a company is facing some real operational heat. Picture a sudden, painful spike in operating costs, right alongside a drop in output. Or maybe it's sparked by a scary increase in accidents on the floor. It could also be that they're rolling out brand new production technology, changing up their product mix, or just dealing with massive worker turnover and strain. Bottom line, these layout planning decisions have huge strategic implications. It's not just interior design, it's survival. So, here is our roadmap for today. First, we're covering the strategy of space, then the 4 basic layout types, designing process and product, mastering cycle time, and finally, optimizing throughput time. Section 1, the strategy of space. Why your floor plan matters to your bottom line. All right, so facility layout, or plant layout as it's often called, is really the strategic physical arrangement of every single resource you have. We're talking workers, equipment, machinery, the whole shebang. The absolute goal here is to optimize workflow, but keep in mind that how often you make these layout decisions completely depends on the facility itself. In highly automated manufacturing, moving these massive, specialized machines is incredibly expensive, so you rarely do it. On the flip side, in labor-intensive services that need adaptability, you might redesign the space all the time to stay flexible. When managers sit down to actually plan this out, they're juggling a whole list of objectives. It's kind of like a giant puzzle where you want to smooth out material flow, boost morale, and save space, all at the exact same time. But spoiler alert, doing all of that simultaneously is pretty much impossible. So managers have to prioritize based on their specific operational needs. For instance, identifying and reducing bottlenecks might be the absolute top priority on a factory floor, whereas improving employee morale might be the core focus in an office that relies heavily on team communication. Moving on to Section 2, 4 basic layout types, the tools in the operational arsenal. There are fundamentally 4 core layout choices available: process, product, fixed position, and group or hybrid layout. These exist to help decision-makers perfectly balance cost, flexibility, and worker convenience while really keeping a strong emphasis on gross material flow and socio-technical considerations. Now, to truly understand the benefits and decision-making techniques behind these, we're going to do a deep dive into the top 2 on this list because they represent the 2 complete opposite ends of the operational spectrum. Section 3, designing process and product. Grouping by function versus sequence. Now, what's really interesting here is how we frame these 2 extremes. In a process layout, which is used for unpredictable, low volume, but high variety demand, workstations are grouped purely by function. Think of a grocery store putting all the dairy together, or a bank separating the tellers from the loan officers. The flow of people or materials is highly variable. But in total contrast, a product layout is built for mass production. We're talking high volume, very low variety. This layout follows a strict sequential assembly line where operations are continuous and repetitive, like car assembly or computer manufacturing. The product literally moves in a dedicated straight line from one station directly to the next. Section 4, mastering cycle time, pacing the workflow. Okay, so once we've chosen a layout, we have to measure its time efficiency. Cycle time is basically the maximum permitted duration at each workstation to complete its tasks before that in-process product advances to the next stage. Think of it like a relay race. Cycle time dictates the absolute maximum time a product can spend at one station before the baton is passed. If one runner is taking way longer, the whole team suffers from idle time. Basically, inefficiency rears its head when one workstation experiences way more idle time compared to the others. So, we've designed the space, we've built the assembly line, but how do we know if it's actually efficient? How do we evaluate these assembly lines and identify those frustrating delays? Well, this introduces us to the tricky puzzle of line balancing, which is how we foster true, measurable effectiveness at the plant. A perfectly balanced line is basically the holy grail of manufacturing. To eliminate idle time, we look for what's called the theoretical minimum of workstations. The whole goal of line balancing is to allocate tasks to the absolute fewest workstations possible without breaking any sequence rules. And you find this by taking the sum of the total process time and dividing it by your desired cycle time. Now, here's a fun quirk about that formula. If you do the math and it spits out a fraction, say 2.4, you always round up to the nearest whole number. So in this case, 3 workstations. Why? Well, actually, it's pretty simple. You can't exactly hire zero point 0.4 of a person. Each workstation requires a real whole human worker to execute the tasks safely and efficiently. Section 5. Optimizing throughput time. The journey from raw material to finished good. This really brilliantly illustrates the overarching timeline. Throughput time maps the complete journey. It's the total time frame it takes to transform raw, baseline inputs, like the raw flour and grain you see here, all the way through the gauntlet into a fresh, finished packaged product. It measures the total amount of a product a company can push through the system within a specific time frame to really drive massive organizational efficiencies. Now, throughput time accounts for 4 distinct manufacturing activities. First up is processing. This is actually turning the raw materials into products. Then there's manufacturing, which includes the processing but adds things like scheduling and quality control. Third is move time, literally the physical movement of materials from one stage to the next. And finally, queue time, which is just the time spent sitting around waiting in the process. But here is the warning: the actual processing often takes up just a tiny fraction of the overall time. It's usually a sluggish move time or a massive backlog in the queue stage that acts as a silent killer to your overall profitability. To keep all these metrics straight, let's break them down side by side. Remember, throughput time breaks down the entire manufacturing journey into those smaller components we just went over. Cycle time, on the other hand, narrows in on the maximum permitted duration at one single workstation. And lead time? That flips the perspective entirely to the customer. It's the total time from when a customer hits place order to when they actually receive the final delivery. I love this perspective. Manufacturing isn't just a single event. It's a highly complex, deeply interdependent series of operations. A bottleneck in just one process will absolutely impact all the others. Analyzing these throughput and cycle times empowers teams to anticipate problems way before they happen, quickly squash bottlenecks, and ultimately turn their manufacturing speed into a massive competitive advantage. Which leaves us with this final thought for you to ponder. Look at your own environment. Is your organization's layout truly designed to optimize flow for the future? Or are your people and your processes currently trapped in a bottleneck of the past simply because the physical space hasn't evolved? Physical space and measured time, these are the unseen forces dictating true operational success. Keep evaluating, keep optimizing, and I'll catch you in the next explainer.